In our previous video, we saw that the nth term of an arithmetic progression is a plus n minus 1 d. Now, let's look at the sum of the arithmetic progression. We need to erase some of our work here. Alright? We want to look at the sum of an AP in a general term, not with example. Now, the first term of an AP, we're going to sum. Sometimes the sum of the nth term of an AP is n. The sum of the first n terms is Sn. This means the sum of the first n terms of the arithmetic progression or of the arithmetic sequence. It is A. And remember, what we want to do is come up with a general expression for the sum of the first n terms of an AP. Just like in the previous video, we reasoned out what would be a general expression for the nth term of an AP, and we got this, a plus n minus 1 d. Let us see if we can come up with a general expression for the sum of the first n terms, Sn. Alright? So, we have A. The second term is A plus D. So we say plus A plus D. Alright? Plus the third term is A plus 2D. Plus the fourth term was with what? A plus 3D. And so on. Right? Plus, alright. We leave out some. Plus. What will be the absolutely last term? Let's put it out here. The last term would be what? It would be A plus, or the last term would be the nth term. Because if it was 10 terms you were adding, the last term would be the 10th term, which would be A plus 10 minus 1D. If you were adding 1,000 terms, the last term would be A plus 1,000 minus 1D. So you're adding n terms. The last term would be A plus n minus 1D. Alright. Just like how you'd have A plus 100 minus 1D for the 100th term. Alright. Let's go back. Plus second to last. What would be the second to last term? If the last term was A plus 100 minus 1D, the second to last term would be A plus 100 minus 1. But, well, no, let's not skip what we need to do. This would be A plus 99. Let's not bother put the bracket. A plus 99D, right? If it was 100 term, it would be A plus 100 minus 1D, which would be the same as A plus 99D. Why this one looks so thick? It's 1. Alright, good. Now, the second to last term would be A plus 98D. You see that? Because we're going one less. So this would be A plus 100 minus 2d. You see that? So in this case, our second to last term would be a plus n minus 2 d, right? Plus, what would be our third to last term? All right. If we had our last term as our 100th term would be 100 minus 1d, which would be 99d. Our second to last term would be 90a plus 98d. Our third to last term would be a plus 97d. But 97d, this would be a plus 100 minus 3d. So, our third to last term would be a plus n minus 3d. Alright? And so on. So you see that? Now, suppose we switch them around. The a plus n minus 1d. We switch it around. And we rewrite the sum of the first n terms. Alright? It's a plus the last term is n minus 1 d. So you see that? Alright. What was the second to last term? It's a minus 2d. So it's plus a minus 2d. Oh no. Let me rewrite that. It's a plus n minus 2d. I was mixed up a while ago. Plus. What was the third to last term? It would be a minus 3d. So it is a plus, it's a plus n minus 3d. So it's a plus n minus 3d. Alright? Now, what would be the, alright, let's see, last, second to last, third to last. The fourth to last term would be what? It would be plus a plus n minus 4d. So we have the last term, a plus n minus 1d. Second to last, a plus n minus 2d. Third to last is a plus n minus 3d. Fourth to last is a plus n minus 4d. And so on and so forth. Right? Plus, whatever it is, we left out some plus. Alright. Remember, we're switching them around. So remember, this is last, second to last, third to last. Alright, we did fourth to last, but in the interest of time and space, we wouldn't really need so many. So let's use the last three terms. The last, the second to last, the third to last. So this is really the last term, second to last term, third to last term. All right. Now, up here, we have the first term, second term, and I should put these in brackets, because because they are separate terms. This is the third term, the fourth term, and so on and so forth. But you get the idea. The third, first, second, third, plus, he leaves out some, then the third to last, fourth to last, and the last. The third to last, second to last, and the last term. So here, we switch these around. The last term, second to last term, third to last term. Plus. And then, what we have is the third term. A plus 2D. That's the third term. Remember, the third term was this. So, this is the third term. Then, plus A plus D. Which term was A plus D again? It was the second term. So, this is second term, A plus D. Plus the first term was A plus A. So this is the third term. Now let's look at what we have. Remember, we leave some out. Plus. These are what we left out. So here we have the sum of the first n terms is A plus D plus A plus 2D. So we have the first three terms plus. And we have the third to last, A plus n minus 3D plus. Second to last, A plus n minus 2D plus. Third to last, A plus n minus 1D. We rewrite the same thing, but we switch them around. The last term is A plus n minus 1D. We put it first, A plus n minus 1D plus the second to last term, A plus n minus 2D. So we put that here, plus the third to last is A plus n minus 3D plus. We leave some out, plus, and then we go down to the third term, second term, first term. All right. So it's the same sum, you know. It's the same sum. Just that we put these like this. Now, we're going to add them. We're adding these terms now. If we add these two, add Sn and Sn, you're going to have my sum of the n term, that's the top one, plus sum of the n term, that's the second one. This plus this. We're adding terms, equal. Let's add these two terms, first and the last. A plus n minus 1. D. Did you see that? All right. So you see that. No. This was the last term. First term plus the last term. Plus now, we add the second term and the second to last term. So we have A plus D plus A plus n minus 2D. You see that? Plus. Then we add the third term and the third to last term. So we have A plus 2D plus what now? A plus n minus 3D plus, that's what we leave out. All right. Now we add these two, the third to last term plus the third term. A plus n minus 3d. Alright? Plus a plus 2d. Alright. Plus now. Plus what? We're going to add these two now. The second to last term plus the second term. So we have a plus n minus 2d. We have that. Plus a plus d. Plus the final addition now. We're going to add the last term to the first term. So we have a plus n minus 1 d plus a. Now let's simplify what we have. Sn plus Sn is 2 times Sn, right? Equal. Alright, a plus a is going to be 2a plus n minus 1 d. Plus now. So remember, what we're doing is deriving the expression. Right? Even though in exam you would get the expression on your formula sheet, but it's important that you know where it comes from. So a plus a is 2a plus d plus n minus 2 d. You see that? Add the a and the a, and then the d with the n minus 2d. Alright? Plus, we add the two a's, a plus a, which is 2a. A plus a is 2a. So we have 2a plus 2d plus n minus 3d plus, and we leave out some things. Alright. So now we add a plus a again, which is 2a plus n minus 3d plus 2d plus a plus a again, which is 2a plus, we have n minus 2d plus d. Remember, you open the bracket, you add a plus a plus n minus 2d plus d. That's what you do, alright? Plus, out here, you have a plus a, which is 2a plus, all you have now is n minus 1 d. Alright. So, what we want to do is simplify them further. So we have 2Sn equals, alright, we have 2a plus n minus 1 d plus. Now, let's open the brackets. 2a plus, this would be d plus nd minus 2d. See that? When you open the brackets. Plus this one now, 2a plus 2d plus nd minus 3d. Alright? So you have that. Plus, have what you left out, plus. Then here, open the brackets, you have 2a plus nd minus 3d plus 2d. See that? Plus 2a plus nd minus 2d plus d plus. Then here you have 2a plus nd minus d. Let's go back now and continue. You have 2 times the sum of the first n terms equal 2a plus n minus 1 d plus, this is 2a plus. Now, this is going to be d minus 2d. This d minus 2d gives you what? Negative d. 1 minus 2 is negative 1. So d minus 2d is negative 2d. Is negative d. So this is nd minus d. See that? Plus, then you have 2a plus 2d minus 3d. Alright, let's write down nd first. This is nd plus what? 2d minus 3d is what? Negative d. It's minus d. So nd plus negative d. It's the same as nd minus d. Plus, you left out some things. Plus, and then we have 2a plus, we have our nd, negative 3d plus 2d is what? Is minus d plus. Alright, we have our next one. This one now is 2a plus nd, negative 2d plus d is what? Is minus d plus, and then we have our 2a. This kind of look like d. Let me just cut off it up here. It's a. 2a plus n minus 1. Well, 2a plus nd, not n minus 1, my. Plus nd minus d. Right? Now you see how long it is? I could have used the last term as L and make it simpler, but we want to show everything all in one. So 2 sum of the first n term equal 2a plus n minus 1 d plus, let's factorize. This is 2a plus, we factorize. D is the common factor here. Normally we would put d at the front, but let's put it over here. D. And what you have in the bracket, remember we factorize d times this is going to be nd, so it's n minus d times this is going to be 1d, so it's 1. Alright, plus. So now you have 2a plus, factorize, put d outside the bracket. Inside the bracket you're going to get n minus 1, right? Plus, you left out some things, plus 2a plus, factorize, you get d outside the bracket is n minus 1 inside the bracket. You see that? Plus, this one now is 2a plus, you factorize, you get d outside the bracket is n minus 1 inside the bracket, plus 2a plus, you factorize, d will come outside the bracket, you get n minus 1 inside the bracket. Alright. Now, what do you have here? You have the 2a plus 1d, 2a plus 1d. You have our 2a plus 1 plus d. Let's say 2a plus d. We have 2a plus d here again, 2a plus d here again, 2a plus d here. So we have a whole lot of 2a plus d. How many of them do we really have? Remember, it's the sum of n terms, so it's n of them, right? It's n number of these things we have. So 2 sum of n terms is equal to, it's n number of 2a plus n minus 1 d. That's what we have. So now we're trying to find the sum of the first n terms. Not 2 times the sum of the first n terms, just the sum of the first n terms. So I have to divide both sides by 2. So the sum of the first n terms is equal to, alright, divide by 2 is the same as multiplying by a half. If you multiply the left hand side by a half, 2 by a half is 1. So we get sum of the first n terms. Multiply the right hand side by a half, we get half n 2a plus n minus 1 d. So there we have it. Sum of the first n term is half n, in bracket you have 2a, open bracket, 2a plus, open bracket, n minus 1 close bracket, d close bracket. Now as I said, this was a long, tedious proof, right? You will get this expression for the sum of the first n terms and the n term in your formula sheet. But if you're studying any STEM area, you need to know the maths more deeply, to understand the maths more deeply than other persons, right? If you're studying to become a mathematics teacher, you need to know the proof from first principles of these things. If you're studying engineering, if you're studying science, computer, you're specializing in mathematics, right? You need to know the proof of these formulas and expressions from first principles, where they come from. You need to understand the basis of these things. So even though it was long and tedious, it was fun. And the reward is getting the proof finally. It's rewarding. Feels good to know that you proved it. You show where this came from first principle. All right? So there we have it. We have 2 things that we looked at in this video and the previous video. We looked at the fact that the nth term is a plus n minus 1d. Right? Let's rewrite them. The nth term is a plus n minus 1d. And the sum of the first n term of the arithmetic progression is half n 2a plus n minus 1d. Wow. Beautiful. Let's put this in a nice gift wrapped package, and we tie it with a lovely ribbon with many colors. We've done very hard work to prove this, these 2 expressions. So we have to make it look really nice, really lovely. We wrap this around. How nice it is. Wow. Alright, so that will be it for now. For other videos, we're going to look at examples of working out the nth term of an arithmetic progression and the sum of the first n terms of the arithmetic progression.